Welcome to my video on the moon phases and the different eclipses. I will be modeling these phases and eclipses using this setup: a tripod and a camera for the view of Earth. As you can see, the tripod is able to swivel around to follow the moon. I'll be taking pictures of the moon just using a lighting setup. And over here is a styrofoam ball mounted on top of a flash mount. Then I've marked out a circle with markings on where to take the different pictures. Over here is my lighting setup, which is just a big work light as my sun. Now I'm going to show you the pictures we took with that setup. First, here you see a new moon, and the new moon is completely dark because the sun rays go hit the back of it instead of reflecting off the front of it and going to the earth. So from the earth you can't see it. Here we see a waxing crescent, and waxing is when the light grows on the right side and the shadow shrinks on the left. It's a crescent because only part of it, the part facing the sun, is lit. Now here we see a first quarter moon, and it's first quarter because it's completely lit on the right side, and it's called a quarter even though half of it's lit, but you can only see a quarter of the moon in total. Here we see a waxing gibbous. Another thing for waxing is that it's like the moon appears to be getting larger, and it's gibbous because a majority of it's lit and only a small sliver of it is shaded. Now here we see a full moon because the entire thing is lit. It's slightly above Earth because it's tilted at a 5-degree angle, so the sun shines straight over it and reflects off the full surface of the moon. Now here we see a waning gibbous, which is pretty much the same thing as a waxing gibbous, except that it appears to be getting smaller. Here we see a third quarter, which is pretty much the same thing as a first quarter, except that the light's on the left side. Now here we see a waning crescent, which is pretty much the same thing as the waxing crescent, except that the light is shrinking and the shadow is growing. This is a lunar eclipse because the Earth is blocking all the light from the sun from getting to the moon. This doesn't happen very often because the moon's at a 5-degree tilt when it goes around the Earth. This is a partial lunar eclipse. It's only partial because only part of the sun's light is reaching the moon. And if you look closely on the edge of it, you can see a fainter outer area called the penumbra and a darker base area called the umbra. Now this is a total solar eclipse because the moon's blocking all the light from the sun again, but this time it's reaching the Earth. There are several ways why total solar eclipses are so rare. First off, being that the umbra of that eclipse is extremely small, and you can only see the total eclipse if you are directly in the umbra. Second off, if it's cloudy out, then you're not going to be able to see the sun, so you won't be able to see the eclipse. Next, the moon is at a 5-degree tilt, so when it comes around, it doesn't necessarily pass in front of the sun's rays every cycle. This is only a partial solar eclipse because only part of the sun's light is being blocked by the moon. You can still see the corona, and this happens more often than Now I'm going to explain gravity. Gravity is a force that attracts physical beings, like a smaller one to a larger one. So Earth's gravity keeps the moon in orbit. If Earth were to just randomly lose gravity, the moon would just keep going out into space. Or if the moon was coming and it had gravity, it would latch on. But if it didn't have gravity, it would just keep flying right past. The moon rotates on its axis at the same rate that it orbits the Earth. So that means that you're always seeing the side the same side of the moon. So if I were to draw like a smiley face on the moon and this would be its rotation. It always rotates so that you're always facing the same side. Thanks for watching and hope you enjoyed this video on the moon phases and the eclipses.